Hi guys, this is the EdExcel GCSE 91 Maths paper 3 from the higher tier, and it's from the November 2019 series. Okay. Question number 1. We have to expand and simplify x plus 5 lots of x minus 9. Well, here, x times by x, that gives x squared. X times by minus 9, that gives minus 9x. 5 times by x, that gives 5x, and 5 times by minus 9, that gives minus 45. And if we collect like terms, we have the x squared, minus 9x plus 5x, that's minus 4x, and then we have the minus 45. Then for part B, we have to factorise fully 9x squared plus 6x. Well, in terms of numbers only, the highest common factor of the 9 and the 6, that's 3. And now in terms of the x's, the highest common factor of x squared and x, that's just x. So 3x times by 3x, that gives 9x squared. And 3x times by 2, that gives 6x. Now for part B of the question, we have to use our calculator to work out the value of 29 squared minus 4.6 divided by the square root of 35 minus 1.9 cubed. So we simply type this into our calculator, so we have 29 squared minus 4.6 divided by the square root of 35 minus 1.9 cubed. So it turns out we get 157.668255. And now for part B, we have to round our answer to part A, correct to 4 significant figures. Well, if we look at the fourth figure, that's this 6 over here, the digit after, which is this 6, is 5 or greater, so therefore this 6 over here gets moved up to the next digit. So it turns out to 4 significant figures we have 157.7. Now for question number 3, a scatter graph shows information about the marks a group of students got in a science test and a maths test. So we've got the maths test mark and we've also got the science test mark, and Jamie got a mark of 34 in the science test. We have to use the scatter graph to find an estimate for Jamie's mark in the maths test. So the first thing we need to do is draw a line of best fit. So if we draw a line of best fit, we have something which looks like this. We want about the same number of points above the line as there are below the line. So might need to make some adjustments, so that looks about right. And then we take a look at this 34 in the science test. So 34, that's here, so we draw a line up like so. And then from here we draw a line across. So if we do that, it looks like we get 39. So we have here 39 for the test score in maths. Now for question number 4, the table gives information about the times taken in seconds by 18 students to run a race. So we've got the time in seconds and then the frequency, and we have to work out an estimate for the mean time. Give your answer correct to 3 significant figures. Well, before we do anything, we first of all need to recognize we have intervals for our time. So we first of all need to work out the midpoint. So the midpoint here is 7.5. Midpoint here, that's 12.5. Midpoint here, that's 17.5. And midpoint here, that's 22.5. And if we work out here the midpoint times the frequency, 7.5 times by 1, that's 7.5. 12.5 times 2, that's 25. 17.5 times by 7, that's 122.5. And 22.5 times 8, that's 180. Then if we add up all these together, it turns out here we get 335. And if we add up all the frequencies, of course, we'll get 18. So, to work out the mean, that's equal to, if we write this down, we've got the sum of the midpoints times the frequencies over the sum of the frequencies. So we have over here 335 divided by 18. So if we work this out, 335 divided by 18, it turns out we get 18.6 to 3 significant figures. So we have 18.6 seconds for the mean time. And of course this is to 3 significant figures. Question 5, we have to write 37 centimeters cubed in millimeters cubed. So to do this, well, what we need to recognize here, to go from centimeters to millimeters, we would have to multiply by 10, and to go from millimeters to centimeters, we have to divide by 10. So to go from centimeters cubed to millimeters cubed, we times by 10 cubed, and millimeters cubed to centimeters cubed, we divide by 10 cubed. So to convert 37 centimeters cubed into millimeters cubed, we multiply by 10 cubed, so it turns out here we get 37,000 millimeters cubed. So we have 37,000. Question number 6. Nimmer was driving to a hotel. He looked at his sat-nav at 13:30, and we've got this table over here. So he looks at his sat-nav at 13:30, and the distance to destination is 65 miles. And Nimmer arrived at the hotel at 14:48. We have to work out the average speed of the car from 13:30 to 14:48. You must show all your working. And if you pay attention to the units, we've got miles per hour. So, first of all, we need to recognize over here speed that's equal to distance divided by time. So, what you can see over here from 13:30 to 14:48, you can see this is 1 hour and 48 minutes. And what we need to do is make sure we're in hours completely. Sorry, this is 18. And the reason for that is because we want to give our answer in miles per hour. So, in total, we've got 60 minutes, that corresponds to the 1 hour, plus the 18 minutes. This gets us over here 78 minutes. And the reason I put this into minutes first is because to go from minutes to hours, we would have to divide by 60. Hours to minutes, we would have to multiply by 60. So if we divide 78 by 60, it turns out we get 1.3. So it takes him 1.3 hours to drive 65 miles. So the average speed, that's equal to the distance. The distance over here is 65 miles, divided by the time, 1.3 hours. It turns out here we get 50 miles per hour. So we have 50 miles per hour. And now for question 7, we have to write in standard form 32460000. Well, for standard form, we need to recognize that the number must be in the form a times by 10 to the power of n, where a is in between 1 and 10. So, if the decimal point is over here, we need to move this decimal point 1, 2, 3, 4, 5, 6, 7 places to the left. So here you can see we have 3.246 times 10 to the 7. And now for part B, writing 4.96 times 10 to the minus 3 as an ordinary number, we begin with the 4.96 and we need to move the decimal place here 1, 2, 3 places to the left. So decimal point goes here, so we have 0.00496. Okay. And now for part C of the question, Asma was asked to compare the following two numbers. So she's comparing A, which is equal to 6.212 times 10 to the 8, and B, which is equal to 4.73 times 10 to the 9. And she says 6.212 is bigger than the 4.73, so A is bigger than B. And we have to question whether Asma is correct, giving a reason for our answer. Well, clearly not, because the 10 to the 8 is smaller than 10 to the power of 9. It's like saying 2 times 10 and 1 times by 10 squared. Obviously 1 times 10 squared is bigger than 2 times 10. So hopefully that makes complete sense. Now for question 8, the diagram shows a regular pentagon and a parallelogram, and we have to work out the size of the angle marked X. You must show all your working. Well, because we have a regular pentagon, it would make sense for us to work out the interior angle. So the interior angle, that's equal to the number of sides, that's 5, minus 2 times by 180, and then we divide this entire thing by 5. So here we get 3 times 180 divided by 5, that's 108. So each interior angle is equal to 108 degrees. Let's just add this into the diagram. We have 108 here, 108 here, 108 here, 108 here, and finally this angle is 108. Now with this parallelogram, the opposite sides are going to be the same, so this is going to be 117, and this angle must also be the same. So this angle over here, which is equal to this angle, we know that angles in a quadrilateral add up to 360, so 360 take away 2 times by 117, and then dividing this by 2, this is 63. So this angle is 63, and so is this angle. So we know from the diagram here, x plus 63 is equal to 108, and therefore subtracting 63 from both sides, x is equal to 45. So we have 45. Now for question number 9, we have to enlarge triangle A by a scale factor of 2.5 with centre 1, 1. So to do this, well, let's just draw on these dotted lines, which will help us guide, which will guide us to what the shape should pass through, okay? So we've got something like this, and also passes through here. So this goes 1, 2, 3, 4, and then 1, 2, 3, 4 up. Okay. So this looks something like that. Okay, so the shape that we're going to draw should pass through these orange lines here. So if we end up drawing the shape, see this point is 1 across and 3 up. So our new shape should be 2.5 across, so 2.5 over here, and 6 up. Okay. So it goes through here, essentially. So let's join these up with a straight line, and then 2 across, so this one's going to be 1, 2, 3, 4, 5 across, and this one is going to join to this one over here. Okay, so that's that question done. Question number 10, we have to solve 9 plus x over 7 equaling 11 minus x. So to do this question, what we need to do is first of all multiply both sides by 7. So I'm going to times this side by 7 and this side by 7. So that 7 cancels with that. So we have 9 plus x on the left hand side, and on the other side we've got 7 lots of 11 minus x. So if I expand out, we've got 9 plus x equaling 77 minus x, minus 7x. And if we take all the x's over to one side, so add 7x to both sides, we have 8x equaling 77 take away 9, which is 68. And if I divide both sides by 8, x is equal to 8.5. And now for part B, we have to simplify 4 lots of y plus 3 all cubed divided by y plus 3 all squared. Well, hopefully here you can see this 2 cancels with this 3 exactly once. So we have 4 lots of y plus 3. There's no need to expand out, because when we talk about simplifying, we should factorize where necessary. Question 11. The probability tree diagram shows the probabilities that Bisma will be late for work on 2 days next week, and we have to calculate the probability that Bisma will be late on exactly one of these 2 days. So she can either be late on a Monday, so we're looking at the probability that she's late on a Monday, and she's not late on Tuesday. Okay, so not late on Tuesday. And what else we can have? She can be not late on Monday, but then she can be late on Tuesday. So the probability that she's late on Monday, that's 0.07. The probability that she's not late on Tuesday, that's 0.98. The probability that she's not late on Monday, that's 0.93. And the probability that she's late on Tuesday, that's 0.11. So if we work this entire thing out, we have 0.07 times by 0.98 plus 0.93 times by 0.11. It turns out we get 0.1709. So we have 0.1709. That's our probability. Question 12. We've got this stem and leaf diagram which shows information about the heights in centimeters of 23 sunflowers, and we've got a key 17 followed by a dash followed by a 3 represents 173 centimeters, and we have to draw a box plot for this information. Well, for us to draw a box plot, we need the minimum value. So the minimum value here, you can clearly see that's 173. We need the lower quartiles. So to work out the lower quartile, we've got 23 pieces of data, so 23 plus 1, and then divide by 4. that's 6. So the 6th piece of data, well, so here is where we've got the minimum. So let's just color code all this. So here we've got the minimum, which is 173. The lower quartile, that's the 6th piece of data. So we've got 1, 2, 3, 4, 5, 6. So this over here is our lower quartile, which is 188. Our median, well, that's going to be 23 plus 1 divided by 2, which is 12. So here the median is equal to 12. So we got 6, 7, 8, 9, 10, 11, 12. So the median is 197. The upper quartile, that's going to equal 6 times by 3, which is 18. So we've got 12, 13, 14, 15, 16, 17, 18. So we've got 209 for the upper quartile. And the maximum value, that's obviously this 219. So all we now have to do is simply plot all these on this. So we've got 173. So 173, so that's here. Then we've got 188 for the lower quartile. So 188, that's over here. We've got 197 for the median and 209 for the upper quartile, and the maximum value, that's 219. So that's this over here. And then we simply join all these up with a line here and here and here and here, and then this to this, and then this to this. So this is our box plot. Okay. Now for question number 13. We've got liquid A and liquid B, which are mixed together in the ratio 2 to 13 by volume to make liquid C, and liquid A has density 1.21 grams per centimeters cubed and liquid B has density 1.02 grams per centimeters cubed, and the cylindrical container is filled completely with liquid C. The cylinder has radius 3 centimeters and height 25 centimeters. We have to work out the mass of the liquid in the container. Give your answer correct to 3 significant figures. You must show all your working. So for this question, for us to work out the total mass, we need the mass of A and the mass of B. So for us to have the mass of A and the mass of B, knowing the densities of A and B, we need the volumes of A and B. What we can do is work out the volume of C and use this ratio to work out the volume of A and B. So to work out the volume of C, we've got a cylinder, so the volume of a cylinder is pi r squared times by h. So we've got pi times by 3 squared, the radius is 3, times by the height, which is 25. So it turns out here we get 225 pi centimeters cubed. And therefore the volume of A, using this ratio here, we've got 2/15 multiplied by 225 pi, which is 30 pi centimeters cubed, and the volume of B, that's equal to 13 over 15 multiplied by 225 pi, which is equal to 195 pi centimeters cubed. So from this we can figure out the mass of A. And the way we can do that is recognizes that density is equal to mass over the volume. So the mass of A, that's equal to the density multiplied by the volume. So we've got 1.21 multiplied by 30 pi. So working this out, 1.21 times by 30, it turns out we get 36.3 pi. Grams. And the mass of B, that's equal to 1.02 multiplied by 195 pi. So working this out, so 1.02 multiplied by 195, that's 198.9 pi grams. So therefore, the mass of C, we would have to add these up. So we've got 36.3 pi plus 198.9 pi. So if we add these up, so if I add on here 36.3 and then multiply this by pi, it turns out we get 738.9 etc. grams. And therefore, for us to work out the mass to three significant figures, it turns out we get 739 grams. Question 14. A group of people went to a restaurant. Each person chose one starter and one main course. So the starter, we have soup and prawns, and for the main course we've got lasagna and curry. And the number of people who chose soup to the number of people who chose prawns is equal to 2 to 3. And of those who chose soup, the number of people who chose lasagna to the number of people who chose curry is in the ratio 5 to 3. And of those who chose prawns, the number of people who chose lasagna to the number of people who chose curry is equal to 1 to 5. And we have to work out what fraction of the people chose curry. You must show how you get your answer. Well, what you can see over here, if we consider the ratio, you can see here that 2/5 of people chose the soup and 3/5 of the people chose prawns. And of those people who chose soup, 5 out of 8 chose lasagna, whilst 3 out of 8 chose curry. And those who chose prawns, 1/6 chose lasagna and 5/6 chose curry. So of the people who chose curry, we have over here, well, the total number of people who chose curry, we've got over here 3/8 of, well, let's write this down, so curry, that's equal to 3/8 of the 2/5. And we've also got 5/6 of the 3/5. Okay, so if we work this out here, we get 3 times by 2 over 8 times by 5 plus 5 times by 3 over 6 times by 5. So if we work out this, we have over here 3 times by 2 over 8 times by 5 plus 5 times by 3 over 6 times by 5. It turns out here we get 13 over 20. So here we get 13 out of 20. Question 15. We have to prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So if we've got an even number, that's going to be in the form 2n. The next even number after it is going to be 2n plus 2. And we're looking at the sum of the squares, so we need to square these and then add them together. So 2n all squared, that's going to be 4n squared, and 2n plus 2 all squared, that's going to be 4n squared plus 8n plus 4. So if we collect like terms here, we've got 8n squared plus 8n plus 4, and we want to show that this is a multiple of 4, so if we factorise out of 4, we've got 4 lots of 2n squared plus 2n plus 1. And therefore, you can see this is a multiple of 4. Question 16. Y is inversely proportional to the square of x. What does this mean? It means here that we have this situation, and when y is 8, x is equal to 2.5, and we have to work out the negative value of x when y is equal to 8 over 9. So if y is inversely proportional to the square of x, we've got y equaling k over x squared. So if we substitute in these known values, we have 8 equals k over 2.5 squared. So from this we can find out what k is. That's going to be 8 times by 2.5 squared. So we've got 8 times by 2.5 squared, which is 50. Okay, so therefore we can see here y is going to equal 50 over x squared, and we're finding out the value of x when y is equal to 8 over 9. So we've got 8 over 9 equals 50 over x squared. So if I multiply through by x squared and then 9, we've got 8x squared equaling 50 times by 9. So x squared is going to equal 50 times by 9 over 8, which is 225 over 4. And therefore x is going to equal plus minus the square root of 255 over 4. So here we get plus minus 15 over 2. We want the negative x value, so we've got minus 15 over 2. Question 17, we've got the graph of y equals x squared minus 3, and we have to use the graph to find estimates for the solutions to the equation x squared minus 2x minus 2 equals 0. Well, if we consider x squared minus 3 and this x squared minus 2x minus 2, to make these the same, if we start off with this x squared minus 3, to get this result over here, we need to subtract off a 2x, and then we need to add 1. So x squared minus 2x, and then the minus 3 plus the 1 give the minus 2. And all this is equal to 0. So this and this are the same. Now the reason I did that is because from here, we've got x squared minus 3. We can say from here, if we take this over to the other side, we've got x squared minus 3 equaling 2x minus 1. And if we draw this graph, we can find out the intersection points. So 2x minus 1, we need to grab a straight line that crosses over here, and the gradient is 2, so we go 1 across and 2 up, so this is 1 up, and 2 up is over here, I think. Is it? So here we've got 1, 2, okay, right. So it looks something like that. Okay, so you have to be a bit careful with the scale over here. So that looks about right over here. So then it passes through this point here. So therefore, this intersection point over here, we'll do it in blue, looks to me as though it's minus 0.05. 0.75, and this one over here is 2.7 approximately. So let's just make our lives easier. Let's just write here x is equal to minus 0.7 and x is equal to 2.7. Okay. Question number 18. The diagram shows a triangle ABC. AB is equal to 3.4 centimeters, AC is equal to 6.2 centimeters, and BC is equal to 6.1 centimeters. D is on the point on BC such that the size of the angle DAC is equal to 2/5 of the angle BCA. We have to calculate the length of DC. So DCA, which one's that? DCA, that's this angle here. We'll call this X. We have over here DAC, that's this angle here, that's equal to 2/5 of BCA, so BCA, that's this angle. So if this angle is X, this angle over here is going to be 2/5 of X. Okay? So hopefully that makes sense. And our job is to find out DC. Okay, well, if I know what X is, I can find out what 2x over 5 is, and then from that I can find out what DC is. So for that I need to use the cosine rule. So for the cosine rule, cos x, that's going to equal 6.1 squared plus 6.2 squared minus 3.4 squared divided by 2 times by 6.1 times by 6.2. And if I work this out, we get 6.1 squared plus 6.2 squared minus 3.4 squared divided by 2 times by 6.1 times 6.2. So we get 0.847. Okay. And therefore we can find out what x is. X is going to equal the inverse cos of this, which is 32.08. So let's just add this to the diagram. This is going to equal 32.08, etc. So this angle over here is going to equal 2/5 of that. So 2/5 of this, that's going to equal 12.83. Okay, so, well, times by 5, divide by 2. So let's just store this into A. And if I do 2/5 of this, let's store this into B. Okay, so to work out that angle DAC, that's going to equal 2/5 of 32.08, etc., which was the 12.83, etc. Now, how does that help us? Well, to figure out DC, I need an angle opposite it, which I've got, and I also need a side, and I need an angle opposite. So I need this angle here before I can do anything else. So to figure out this angle, the angle ADC, that's going to equal 180 minus this 32.08, etc., minus the 12.83, etc. So we've got 180 take away A, take away B. It turns out we get 135.08. So here we get 135.08, etc. So let's add this to the diagram. We've got 135.08. Okay, so now I can use the sine rule. So we've got DC over the sine of the angle opposite it, which is sine of 12.83, etc. And this is going to equal 6.2 divided by the sine of 135.08. So let's just store this into C. So to work out DC, that's quite straightforward. DC, that's going to equal 6.2 times by the sine of 12.83, etc. divided by the sine of 135.08, etc. So if we work this out, we've got 6.2 times by the sine of this angle here divided by the sine of this angle here. So it turns out we get 1.95, etc. And therefore to three significant figures we get 1.95 centimeters. Question 19. The graph shows information about part of a cyclist's journey, and we have to work out an estimate for the speed in meters per second of the cyclist at time 6 seconds. So to do this question, we need to draw a tangent to the curve at t equals 6. And if we do that, if we draw a tangent, we have something looking like this, okay? Now why is that important? Because if we find out the gradient of the tangent, that'll give us an estimate for the speed. So the gradient, the speed is equal to the gradient of this line, so the change in y, so let's just write this down properly. The change in y, that's going to equal 20 meters, and the change in x, that's going to be 9 take away 3, which is 6. So the change in x is going to be 6 seconds. So the speed is going to equal the change in y, 20 meters, divided by 6 seconds. So that's going to be, what's it going to be? It's going to be 20 divided by 6, which is 3.3, etc. So we get 3.33 meters per second. Question number 20, we've got the first 5 terms of a sequence and we have to find an expression for the nth term of this sequence. Well, normally what we'll do, it's either going to be a Fibonacci sequence, a quadratic sequence, or a linear sequence. First thing we can do is find out the difference between each of these terms, and if we do that, difference between minus 1 and 0, that's 1. Difference between 0 and 3, that's 3. Difference between 3 and 8, that's 5. And the difference between 8 and 5, that's what is it? 8. No, it's not, it's 7. And we now work out the difference between these terms, so difference here is plus 2, difference here is plus 2, and difference here is plus 2. Well, it looks like we're going to get a quadratic sequence then, because if I do 2, which is this difference, divided by 2, turns out we get 1. So therefore we have a 1n squared. And if I write down the 1n squared terms, we have 1, 4, 9, 16, and 25. And if we write down our sequence, which is shown here, actually we'll write it in black. So if we write down our sequence, we have minus 1, 0, 3, 8, and 15. And now if we work out the difference between the sequence and the 1n squared terms, minus 1 take away 1, that's minus 2. 0 take away 4, that's minus 4. 3 take away 9, that's minus 6. 8 take away 16, that's minus 8. 15 take away 25, that's minus 10. And now if we work out the difference between each of these, we get minus 2. Okay, so what does that tell us? Well, it tells us we have a minus 2n for our linear bit of our quadratic. And to work out the 0th term, we do the opposite of minus 2, which is plus 2. So if I do that, it turns out here we get 0. So our constant term is 0. So therefore our quadratic sequence is going to be n squared minus 2n. Question 21. When a biased coin is thrown 4 times, the probability of getting a heads is 16 over 81. And we have to work out the probability of getting 4 tails when the coin is thrown 4 times. Okay, so we've got the probability of heads. Well, if we work that out, the probability of a head, we can use that to find out the probability of a tail. And then we can find out the probability of getting 4 tails. So, probability of getting heads 4 times, we've got the probability of a head times by the probability of a head times by a probability of a head times by the probability of a head. This is equal to 16 over 81. So we've got the probability of a head to the power of 4, which is equal to 16 over 81. So therefore the probability of a head, that's going to equal the 4th root of 16 over 81, which looks like 2/3. So therefore the probability of a tail, that's going to equal 1/3. Hopefully that's obvious. Obviously probability adds up to 1. So therefore getting a tail 4 times, that's just going to be the probability of a tail to the power of 4. So we've got 1/3 to the power of 4, which is 1 over 81. So it turns out here we get 1 over 81. Question 22, we have to show that 7x minus 14 over x squared plus 4x minus 12 divided by x minus 6 over x cubed minus 36 simplifies to ax, where a is an integer. Okay, so to do this question, let's factorize where we can. So if I consider this 7x minus 14, we have here 7 lots of x minus 2. And we divide this by x squared plus 4x minus 12, which I can factorize as x plus 6 lots of x minus 2. And this is going to be divided by, well, x cubed minus 36x, I can factorize out an x. So I've got here x lots of x squared minus 36. So here I'm going to be dividing. And on the top I've got x minus 6. So how do I do now? Well, over here you can see the x minus 2's cancel. So we have 7 divided by, that's a bit of a big line, 7 divided by x plus 6 divided by, again that's a bit of a big line, well here, what you can hopefully see, we have x lots of x minus 6 lots of x plus 6. Okay, so that goes on the bottom, and on the top we've got x minus 6. So here you can probably see that the x minus 6 cancels. So we are left with 7 over x plus 6 divided by 1 over x lots of x plus 6, and when we divide a fraction we change the divide to a times and then we flip the second fraction. So here we've got x lots of x plus 6 over 1, and here you can hopefully see that the x plus 6 is cancelled on the top and the bottom, so we have 7x. So therefore a is equal to 7 because we divide by 1. Question 23. The diagram shows a sector OACB of a circle with centre O, and the point C is the midpoint of the arc AB, and the diagram also shows a hollow cone with vertex O, and the cone is formed by joining OA and OB. So hopefully you can see by joining this line to this line here, we get with this cone here. And we've been given the formula for the volume of a cone and the curved surface area of a cone. And the volume of the cone has volume 56.8 centimeters cubed and a height of 36 centimeters. And we have to calculate the size of the angle AOB of the sector OACB. Give your answer correct to 3 significant figures. Okay, so what can we do? Well, we've been given the volume, we've been given the height. So from this we can find the radius of the cone. So we've got 56.8 equals 1/3 times by pi times by r squared times by 3.6. So we can use this to find out what r is. So r is going to equal 56.8 multiplied by 3 divided by pi times by 3.6. All I've just done over here is just rearrange for r. So then I'll square root this. So if I work this out, we've got the square root of 56.8 times 3 divided by pi times by 3.6. So we get 3.88, etc. centimeters. So I think if we store this into A, that might be a good idea. So in terms of the diagram, let's try to draw everything as add everything that we know. So here we've got essentially the height. So this is the height of 3.6, and we've also got this radius over here. The radius here is this 3.88, etc. So what can we do with that? Well, we can work out the curved surface area of the cone to find out what L is. Okay, so to do that we can use Pythagoras, because essentially we've got a right angle triangle. So L, that's going to equal well, through Pythagoras, that's going to equal 3.88, etc. squared plus 3.6 squared, square rooted. So I've got this squared plus 3.6 squared, and then square root this. That's equal to 5.29, etc. So let's just store this into B for now. So that's what this length here is, okay? This length over here is 5.29, etc. centimeters. So let's just add on the units everywhere where we're working out stuff. Okay, so how does that help us? Because now we can work out the curved surface area of the cone, and the curved surface area is going to be the area of this bit, isn't it? And AO, which is equal to OB, that's going to equal this 5.29, etc. So this is going to be 5.29, etc. centimeters, and this is also going to be 5.29, etc. centimeters. Okay, so what can I do now? Well, from this I can work out the surface area of this bit, which is going to be pi RL. So the surface area, that's going to equal pi times by the 3.88, etc. times by the 5.29, etc. So if we work this out, so times this value, so times A by B, it turns out we get, oh, and then times by pi. So I'll get 64.57, etc. centimeters squared. So that's the total area. Now another way of working out an area is by considering the area of a circle, the proportion of an area of a circle. So we've got the major segment and the minor segment. Sorry, the major sector and the minor sector. So that another way of working it out is AOB, the angle AOB, divided by 360, multiplied by pi r squared. Now this r that we're talking about is this over here, this radius, essentially. So we multiply by 5.29, etc. squared. And this is equal to 64.5, etc. And all we have to do is just rearrange for AOB. So AOB, that's going to equal 64.5, etc. multiplied by 360 divided by pi times by 5.29, etc. squared. So if I work this out, so times this by 360 and then do this divided by pi times by this value squared. So it turns out we get 263.95, etc. So to three significant figures, we get 264 degrees to three significant figures. Okay, so that's that question done. Question 24, we have OX, which is equal to the vector A, and OY, that's equal to the vector B, and P is the point on OX such that the ratio of O to P to P to X is equal to 1 to 2, and R is the point on OY such that OR is equal to RY, OR to RY is equal to 1 to 3, and we have to work out in its simplest form the ratio Z to P to Z to R. Show while you're working. Okay, so we've got OX, which is equal to A, so this entire thing's OX. So OP, that's going to be 1/3 of OX, so this over here is going to be 1/3 of A. And PX, therefore, is going to be 2/3 A. Now OR to RY, that's equal to 1 to 3, so OR, that's going to equal 1/4 B, and this is going to be 3/4 B. So that's that, okay, and we've also got this one. Now why does that help us? Because we need to work out first of all what ZP is. So starting at Z, finishing at P, how can we get there? Well, for that I need to know what OZ is, which is equal to XY, because we have a parallelogram. So OZ, the vector OZ, that's going to equal the vector XY. So this is going to equal OY minus OX. So OY, that's equal to B, minus OX, which is equal to A. Okay, and ZP, starting at Z, finishing at P, how can we do that? Well, if I know what this vector is, OZ, which I just said was B minus A, this is also B minus A. So what I can do now is work out what ZP is, starting at Z, finishing at P. So ZP, that's going to equal OP minus OZ. So we've got OP, which is 1/3 A, minus OP, which we've just said is B minus A. So if I tidy this up, 1/3 A plus, because the minus and the minus give a plus another A, that's going to be 4/3 A. And then we've got minus B. And if I factorize out the 4/3, we've got 4/3 lots of A minus 3/4 B. Because obviously 4/3 times 3/4 gives the 1. So that's what ZP is. let's find out what ZR is using a similar method. That's equal to OR minus OZ. Do I know what OR is? Yes, I do. That's a quarter B. And OZ, do I know what that is? Yes, I do. I've just worked that out. That's B minus A. So here, minus and a minus give a plus. So here we end up with A, and 1/4 B minus another B. That's minus 3/4 B. Okay. So what you can see here is if you compare this with this, so if I compare this bit over here with what we have over here, which is the same, you can hopefully see here that ZP is equal to, so ZP, that's equal to 4/3 of ZR. So when we come to find the ratio of ZP to ZR, you can see here ZP to ZR, that's going to equal 4:3. Okay, so here we have 4:3.